Hello students, we are solving a question on wave optics. This is from 28th January shift 1 JEE Mains 2026. The question says there are two statements. Statement 1 says a plane wave after passing through the prism remains as a plane wave, but when passing through a small pinhole may become spherical wave. The statement 2 says the curvature of the spherical wave emerging from a slit will increase for increasing slit width. So we have to verify these two statements. According to me, statement 1 is true because we know that the wavefront is always normal to the direction of propagation of the rays. So a parallel beam of light entering the prism after two refractions will still be parallel. Why? Because this is refraction from the plane surface, right? So if the beams are parallel, the normal to the surface is also going to be parallel to each other. Here also, the normal to the surface is going to be parallel to each other. So, a parallel beam of light will be emerging also as a parallel beam of light. So, a plane wave is going to remain a plane wave because wavefront for a parallel beam of light is always a plane wavefront. Although the wavefront will be tilted a little bit with respect to the initial wavefront, but it will still remain a plane wavefront. Whereas if you have a small pinhole in a wall, that pinhole will convert a plane wavefront into a spherical wavefront because the pinhole causes diffraction. It will cause flaring out of light, and light flares out from a source, causing the formation of secondary spherical wavefront, right? So now this point behaves like a point source of light, and a point source of light generates spherical wavefront. However, statement 2, which says that the curvature of the spherical wave increases on increasing the slit width, is actually wrong. See, if you increase the slit width, the flaring out of the light will reduce, right? It will flare out less. If light flares out less, it's going to give more plane wavefront compared to curved wavefront. Because if you increase the slit width a lot, you're going to ultimately get plane wavefront. You will not have any flaring of light, right? So remember, the slit, when the slit is smaller, the flaring out of light is more. How am I saying that? Recall, in diffraction, what is the angular position of the first minima? The angular position of the first minima is sine inverse of lambda by d, where d is the slit width. So if you increase the slit width, theta will decrease. Sine is a increasing function, right? So if you increase the slit width d, theta will decrease. Means flaring out will decrease if you increase the slit width. What if you make the slit width infinity? If you make it slit width very large compared to lambda, you will see that theta will almost become 0 degree, means there will be no diffraction. And ultimately, if you have a very wide slit, you're going to get a parallel beam of light and you'll get a plane wavefront. So if you increase the slit width, the wavefront becomes more and more plane, and hence we can say the curvature actually decreases, because for curvature to increase, we want it to become more and more curved, right? So the smaller the slit width, the larger the curvature. But if you make larger slit width, you will get smaller curvature. So option 2 seems to be the correct answer.